Okay. All right. Thanks everyone for another week of our meetings. As I mentioned in the email earlier to the group, the next 3 Fridays I'll have to cancel, which you already probably got the cancellations in your calendar, due to my travels and meetings. So I imagine other people. Summer's coming up, so it might be harder for people to come anyway. Um, all right. So no news on any new papers, other than hopefully this preprint here. Maybe by the time we have our next meeting in July 21st, this paper hopefully will be accepted. But we'll see. Okay, and then just the same updates as every week. We're having the long COVID folks. There's a case report that's we're working on with Al Delaney and other folks. That's moving along. So people want to help out, let me know. All right, let's dive into the COVID news. So you might have heard recently that there's the new X. Right now the XBBs are 1.5, and there's a new XBB 1.6 that is slowly creeping up. Not that it's increasing the cases, but or severity for hospitalizations, but they're talking probably by the fall, Pfizer, Moderna, and Novavax are seeking for FDA approval and for a next round of shots to include the XBBs, because the bivalent that you get now is a BAs, BA.1, 2, 5. So people wanted to wait until the fall to redo their booster. It's probably good. The XBBs will be available then, hopefully, as a new version of the vaccine for the bivalent boosters. And just in the theme of vaccines here, this study that just came out now, a new study, looking at, again, this is probably intuitive for people here, but it's looking at did a pretty comprehensive study for children under 12, and looking at how well the bivalent boosters and the regular vaccine that you get and the bivalent might be effective. And of course, is not to our surprise, it's showing, of course, if you have the boosters and the bivalent, with Omicron, it provides a better protection for severe outcome in children under 12. But the thing that they showed is that the waning immunity still is happening gradually over time. I think they showed, this is one figure from the paper here, but they showed, I think after 5-6 months, that's when the waning immunity happens. So similar to what we know happens with adults too. So I guess that data really wasn't clear until this paper came out about the waning immunity in children. But the good thing is, it's again another paper enforcing that children under 12 or people from all ages, the vaccine will be helpful for them, and the bivalence will definitely help on the different variants, because they even tested on XBB.1.5, or not tested, but they observed the cohort population from the most recent variants that are floating around. So this editorial came out, and I think this might be a little strong language here, saying, COVID and Alzheimer's, the link is finally established. I might say potentially established, but this might be interest to Steve and the inflammation group of how they're establishing this link is through the RAS pathway here, as they talk about, in this article, the renin-angiotensin system. So basically, we know that in Alzheimer's literature, this is like a little snippet from this article here. This is now the abstract's available in EPUB in this editorial. But basically, we know for Alzheimer's that these factors like AT1R and RAS are heavily involved, that then eventually form the plaque formations, beta amyloid and things like that. And this is what they're linking here to in this editorial, saying, due to the increases in activation of RAS and overactivation that is happening due to COVID, and then of course we see this too in our information paper, that this is a finally established link, but I'll say potential link, because still, I think there has to be more studies done. But it could explain, that some of the things that the doctors are showing and seeing that there is advanced cases of Alzheimer's happening for young folks that shouldn't have been happening pre-COVID now. So this was interesting, but I'm waiting for access to the actual paper to see what there might be more into the paper as opposed to this review of it.
Yeah. Please send it out, option to the inflammation group, very quickly.
Yeah.
I'm surprised they attribute it all to vasoconstrictive because, as you know, increased RAS can lead to vascular leakage,
Mhm.
which in our COVID inflammation paper seems to be more dominant than anything we can attribute to constriction. So that's interesting. We can talk about it.
Yeah. Yeah, I'll send this. Yeah, go ahead, Kevin.
Well, I'd be curious too if they identified brain regions in that paper that they might either where RAS changes in RAS were observed, because I mean that's been an issue with this inflammation paper. So
Yeah. So I can't. I'll send the. Sorry, go ahead, Kevin.
You know, with Alzheimer's, you observe amyloid in fibrinogen or fibrin disposition associated with vascular disease, and I mean that's been well known for a while, and it's what I would have expected with the rodent data, except it just wasn't seen. So
yeah, we didn't have this granularity for that in the data.
Yeah.
Yeah, I mean, so I'll after the meeting I'll send over the DOI link for this, and if anyone has access through the institution to the actual paper, then that may be helpful to look at. It looks like it was more of
there have been other papers published in the COVID literature that shows a relationship in gene expression between COVID patients and Alzheimer's patients. So that's also of interest. For example, roughly 2 years ago, there was a paper published that showed a correlation or correspondence between, I think it was about 40 genes associated between COVID patients and Alzheimer's disease. A lot of those involved calcium signaling pathways. So.
Yeah, I've seen some of those that you talk about. Yeah, but yeah, we'll see what. I mean, this looks like to be more of an editorial, so they might be referring to a bunch of those papers you mentioned, Kevin. So, as I said, if someone could get access to this, it might be, or maybe once it's the EPUB is now once it's actually submitted or released, maybe I'll have access to it too.
And they're making a distinction with Alzheimer's disease, but you could also make one with Parkinson's, for example, and others. So.
Right. Yeah, exactly. All right. Yeah. So we'll see if there's more data. This might maybe generate even more data coming out. This is one little, the CDC releases their papers once in a while. This one I thought might be of interest to folks like Nydia and for collaborators out in the University of Ghana, since they're looking at zoonotic and interchange with animals. But this was like a study they did. They looked at this in the zoo, in the African lion zoonotic cases where the lion got infected with COVID, luckily survived, but then they had to euthanize the lion for other supposedly not COVID cases. Maybe the COVID lion did have long COVID and we didn't know. But they're talking about the precautions that people had taken during this time in 2021, and how the line got infected. And then this would be more of a article to show like this transmission can happen in other various settings like this. They take that precaution in the future if that's the case. But again, this is a smaller cohort there. It was like N of 1, and then there was like 1 to 6 people they were looking at that taking care of it. But further, we knew that there was from human to animal transmission was happening, but this was one more of a comprehensive one they looked at. So looking at some long COVID papers and news, the HHS in the U.S. They published this. It's a pretty good comprehensive guide, I guess you could call it, linking the symptoms to mental health and long COVID. I think they're trying to make definitions easier for clinicians to look at. They provide clear definitions in here of what long COVID should be according to the HHS. And they also provide like estimations of vaccinated, non-hospitalized, hospitalized, and what is known currently with long COVID cases and the chance of getting long COVID. Like we know with vaccinated, pretty much now is 10 to 12%. And some people say it's lower. Some people even say it's 5% chance of getting long COVID. But it's being conservative with this. And then it's defined, the mental health symptoms associated with long COVID. So I guess this is more of a guide for clinicians so they don't dismiss people when they're coming in and they're saying they have these symptoms and maybe kind of define it for long. So if people want to take a read, this is a nice PDF. It's like a 29-page PDF really defining what they consider as guideline for clinicians to look at and in general for people for mental health issues and psychiatric disorders related with long COVID.
Afshin, is there any report on connection between shingles, increased shingles risk and long COVID? I've got two anecdotal data points, but I don't see it listed here amongst the long COVID risks.
I've never heard of that before, but I might be missing it. Does anyone else know? Or have heard any kind of other evidence of that? I mean, I won't be
I'm
surprised.
pretty sure that.
Yeah, sorry, go ahead.
Yeah. I'm pretty sure, Afshin, that there is a connection between and some other cases of herpes zoster or reactivation of this virus in patients that had COVID, and also there is a couple of papers of activation due to COVID of herpes zoster. I gotta find out the papers and you.
Yeah, put in the link. That way the reader could look at it too. Yeah, as I said, I mean, we know reactivation like of an EBV occurs, right, with COVID. So I'm not surprised if other these dormant viruses being reactivated.
So those anecdotal data points spurred me to go and have the shingles jabs.
Yeah.
Because it's devastating when you're older.
Yeah, exactly. Yeah, I know some people have had it. Yeah, it's not a fun virus to get or reactivate, I should say. Yeah. Yes. If Chris finds the papers, we'll put it in the chat, or I could share it later too by email to the group. Yeah. Yeah. So I mean, that's something I think I haven't seen too many studies, but if Chris has seen them, that'd be definitely interesting to look at. And I do. Oh, Chris put it just in the chat. Thanks, Chris. And I definitely think, Riza, that could be a good public message to give to folks. If you haven't had your shingles vaccine and you're over 50, do it because COVID could cause the reactivation, and you don't want that another additional symptom related with COVID infections happen. Okay, so if anyone else finds any papers like that, put it in the chat. So this is a preprint that people might be interested in reading, and it's in Lancet, so take a look. But the basic gist of this paper is that they're looking at dysfunction of the vagus nerve and associated with long COVID, so this dysfunction that happens with the vagus nerve. So the key findings are basically it's like a central pathogenic role they're claiming, and they looked at multiple clinical trials where non-invasive vagus stimulation could be underway to potentially help long COVID patients. But this is a data set. This is their findings. This is a clip from their abstract. So they said participants for the study was mostly women around the age of 44, so fairly young. And they categorized different symptoms associated with people who are recovering from COVID, who had long COVID, and then uninfected controls they had. And then the post-COVID condition, PCC, is were more likely thickening of this hypergenic vagus nerve in the neck ultrasounds that they took. So, and then this is like the characterizations of what different groups might be related to long COVID recover unaffected, and the vagus nerve and the different conditions related with that. This heat map up here. But this is just an interesting study. Look at that. They didn't look at the biology related to this, but more of images and relationship to long COVID and what they were experiencing. But it's preprint, so we'll wait. Yeah, go ahead.
Yeah, there have been a few studies involving vagus nerve stimulation in COVID, which has kind of surprised me. Of course, I did a lot of my early work years ago in VNS, and at that time, and we're talking roughly 30 years now. Of course, there was a lot of anticipation that VNS and other similar nerve therapies, nerve stimulation therapies, might be quite useful, particularly enhancing immune response to infection. And so it's taken a while, actually. NIH has kind of supported some of this. I'd be curious to see where the funding for this research comes from. But NIH only recently, within I think it's last 6 months to a year, has really voiced any interest in studies involving VNS. So hopefully this might be a therapy for people, patients refractory or intractable long COVID. So for me, it's kind of exciting. For those who may or may not know, VNS was originally approved by the FDA for treatment for intractable epilepsy, and it shows about a 30% improvement in efficacy for patients unresponsive to other types of treatments. So, I'm really looking forward to seeing more on VNS and this study in particular.
Yeah, no, it's great. It looks like this study is mainly done from people in Europe, so the funding was somewhere in Europe, taken not NIH for this one, unfortunately. But yeah, that's interesting. Yeah, no, it's great to hear. Yeah, well, I guess any relief for people who are getting long COVID for different symptoms sounds like it's promising.
That's exactly right.
This is a paper that I think the inflammation group came out earlier this month, and I missed it. This is probably 3 weeks ago, and I missed it. But I figured now we could go over this paper because they did a pretty nice job in this paper. It's in Nature Communication, looking at serum from COVID, post-COVID or past. They're referring here to post-acute for the long COVID patients, post-acute sequelae. Sorry, SARS-CoV-2 long COVID patients. And or long COVID, and they had a popular. This is just the highlight from their abstract here. This is a key thing about their study. They looked at 55 individuals who had long COVID, and the symptoms lasting longer than or equal to 60 days. So long after supposedly the virus has left your system. And then they compared it to onset of acute infection or acute individuals and non-infected or uninfected individuals. So that's their population cohort. So 55 seems it's low, but it's a decent number still. And they collected the serum, and then they basically did targeted proteomics in a sense, and then they started looking at things that related to this. And I'm going to go over some of the figures here, and I guess there's a lot of nice overlap with the inflammation paper that we're working on. Just to zoom in on the heat map here, they did basically a single cell GSC, I did gene set enrichment analysis on the protein data from the 55 individuals in the serum. And these were like the key pathways. And what happened was, I guess in their clustering, it broke into 5 specific cluster groups, the data itself. And they have the age, status, sex, so on, and the symptoms that they have for long COVID is fatigue, pulmonary, cardiac, and so on and so on. And you can see a bunch of inflammatory related pathways are popping up. And then we're going to talk about some of the key ones. They really honed in on NF-kappa and TNF signaling. And the clustering we'll get into in a second. Between the clustering, this is the bottom half of this figure. And then they looked at what they did. One thing they did is looked at BMI thresholds in context of the different groups that are clustered. They looked at non-inflammatory, inflammatory signals based on the signals, and then basically one thing that they showed is BMI, increasing BMI would increase your association with long COVID-related persistence of these inflammatory signals, which might not be too much of a surprise. Same with aging. You see, aging has the same impact, which again might not be too surprising. Here they looked at interferon gamma as one of their key factors. The interesting key points of this figure was that 2 of the clusters, if I go back, cluster 4 and 5 are here, kind of the pattern, showed like marked enrichment from inflammatory modules for interferon type 1, type 2 signals, and TNF and NF-kappa, which is one of the key things that they take-home messages they say of this paper are key for long COVID patients for inflammatory conditions. And then this clusters 4 and 5 are predominantly included, past patients, so that's why they focused on those 2 clusters. While, like for example, cluster 1 was only uninfected or recovered patients, and 2 and 3 is a mixture of all 3. So in this group here, 4 and 5 was majority of them were past, as you can see from the pink bar here on top. While you can see why this is uninfected, this is kind of started being a mix of that. So then the cluster 4 and 5, they said, are probably the most important pathways that are popping up specifically for long COVID in their analysis. That's why they started categorizing 4 and 5. And you can see the patterns in the molecular biology that's happening with that. And then they're showing the BMI, some things related with BMI and increase in long COVID related inflammatory. Some of these genes are familiar from our paper, some are not. That is we're working on. There's some other ones here related with age. Again, some genes you might recognize. Feel free to jump in and interject.
So cursory analysis, this is Steve option, looks like a high overlap between the peripheral blood cells that we've done the inflammation paper with you on this EPIC or whatever that circulate. Mm-hmm. The transcriptomic changes just quickly look like they highly overlap the protein changes here. Is that your impression?
I think so, yeah, because that's why I recognize a lot here. I have to do it. Yeah. I have to go back and forth and look at those figures.
No, the interferon 1 and 2 and all the different types, they really look like just quickly a real overlap, which is interesting at the protein and the transcript level. Yeah.
Yeah.
Yep.
Yeah, exactly. So they might see more insight as I'm showing you some of the rest of the figures. Here they looked at how the pathway clusters and they started clustering different pathways based on those groupings of the different cluster IDs, and they said these might be the key pathways, and these are the ones surrounding the key pathway clusters 4 and 5. You can see there you go, zoomed in version. Sorry, I know I had one. So this is the clusters 4 and 5, specifically related with the long COVID folks. And these are the specific pathways, and these are the ones in the middle, of course, share between 4 and 5, and then these are the key pathways, maybe specific or unique to maybe the cluster 5 as the more dominant long COVID group, as opposed to 4 had some mixture. But you can see pathways that might be recognizable. Again, there are TNFs in here, and coupled with IL pathways. They have some energy metabolism. They didn't really focus on mitochondria or look at that, but there's maybe indirect pathways here related to mitochondria-related activity. And then in the middle, you can see, as Steve, you pointed out, the interleukin pathways and stuff is here. Reg-I's here. And then some of the other key inflammatory, again, pathways or proteins, I should say, not pathways. This is the list of some of them that they pointed out. Again, some of these, I think, as Steve, you mentioned, this does overlap with what we're showing, a lot of these. And again, they based the analysis based on the clusters. Again, 4 and 5 are the key, I think, for passing. You can see the increase in these inflammatory markers as you go into those groupings of patients with those clusters. And then this is just other ways of showing the data, I think, over time. Here, days post-infection, things like that. You can see it being persistent over those groups. And this is their overall top 50. So this was, I think, probably might be illuminating for folks in the inflammation group again, and other people too. So top 50 overall proteins, what they claim are based on like all their clustering and all their, like this plot, this top network figure here is clustering of the genes and what they're considering within past related patients. And you can see, for example, they categorize them also with, mild symptoms, other symptoms, and so on. And the cluster IDs on top, you can see that 1, 2, 3, 4, 5 and 4 are here. But you can see the genes that they're saying the top 50 that are related specifically for the long COVID clusters, and you can see this distinction here. The clusters 1, 2, 3 are basically not very dominant in their protein expression, while you can see like this is primarily cluster 4, these genes here. These genes are cluster 5. The more predominant for long COVID than the mix, and then this. I had a bottom half too. Maybe I can delete that one. But the bottom half is here. I still need to delete it, but the bottom half is here. These genes here that are dominant in both clusters, 4 and 5. You can see here. But that's this paper, so I think this might be of interest. I'll send you guys the link, again, something again, maybe that.
Offsheen, very briefly, it's just this amazing overlap, and you see in the top panel CXCL10, CXCL11 in both in animal models and in data from humans circulating. That's been a real sign of severe disease. Those things being up and I assume it's up here. I can't read
Yeah,
it.
yeah, it's up. Yeah, exactly.
Yeah.
Yeah,
Amazing.
yellow's up.
It's amazing overlap with the transcripts. Yeah.
Yeah. I think this might be something to reference in our discussion in the
I think
paper.
I think it's mandatory.
Yeah. Especially since this just came out earlier this month, and then it's long
Absolutely.
COVID though, not acute. But this is a discussion,
Right, and we
maybe.
can't comment because we restricted
Right.
it mostly to the circulation in the shorter term, but it's intriguing for sure. Yeah.
Right. Yeah, this is a good discussion. I think greater than 60 days versus we're lower than 21 days in our paper, but
Yeah.
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 So I'll send this link to folks and people could dive into the look at the actual data. But the data is also available publicly too now, so we can look at the protein data and do additional analysis on it later for next papers. Something we could consider. I should keep a list of all these papers and somewhere as a resource for us to mine. That's the papers. I don't have any other discussion on this unless people have other questions on these papers before I move on to the variant updates and the tracking. Oh, and I see, Chris, thanks. You put additional papers for the reactivation of the herpes viruses. So people look in the chat regarding Riza's questions with shingles. And Al, I see your comments there. Yeah, some of these cytokines you mentioned are rheumatoid arthritis. Yeah. So that's a good point for the long COVID case study that we're doing is related with arthritis, as Al points. That's why Al is making this comment. So this is something you might want to also use for that long COVID case study to look into. Okay. Yes, very good point. Okay, so the dominant variant again is still XBB.1.5, but as you see, all these other XBBs, and I'll show you in the CDC tracker shortly, are coming up. The good news is still there's that downwards trend of the wastewater. I mean, it's sort of plateauing, but still going down nationally in the U.S. And you can see the variants. This is last updated. Okay, this recently updated because sometimes every 2 weeks. And the sequencing. This up here but the sequencing itself is usually a 2-week lag behind. But it looks like it's probably in the beginning of June here because since they're sequencing the wastewater, sometimes it takes 2 weeks for it to show up in real time. So this is from 2 weeks ago, and then if you see their updated version 2 weeks from now, it should reflect what's happening now for the variants in the wastewater. So what's interesting is, if you look at the county-specific levels for wastewater, you usually see this trend. This is where I live. You see little spikes going up and down, little wobbles, but usually it keeps going down from what I've seen in most regions. But you might see these little wobbles up and down, but still a downward overall trend. So I guess it's good news, but people are still getting infected over here, and people are experiencing not hospitalizations, but still it doesn't sound like it'd be fun to get long COVID, or the chance of 10% getting long COVID is not good. So this is the variants here. Again, as we said, XBB.1.5 was the previous dominant one, back in March, and then slowly these other variants are popping up. And you can see now between the competition, at one point people thought it was going to be 1.16, which is here, but then 1.9 is also taking over. But then there's this newer ones that are popping up, this 1.16, which is the salmon color, you might call it here, and this XBB 2.3 that's been coming up to it, you see, and supposedly there's some growth advantages that are making it more competitive. I guess Nidia, you probably know more about that than I would. I don't know if you might make a comment about XBB.2 that's been becoming a little more dominant. Putting you on the spot, Nidia.
No, that's fine, but not really. I haven't been tracking the mutations that, are producing this growth.
Yeah, I haven't been. Yeah. But they're not too far for symptoms, from what I've heard. It doesn't really cause any new symptoms, from what I've heard, or
Right.
increase in hospitalizations or anything like that.
Mhm.
Which is a good thing, I guess.
Yeah.
And then the last slide here, just looking at the global trends. Again, the cases are not as reliable as we all know because of the lack of surveillance that's happening everywhere around the world, and people are testing at home more, of course, not reporting. So usually looking at hospitalizations in ICU. And someone requested last week, which is a good suggestion, show from the beginning of, the pandemic, what's happening. So as opposed to my little zoomed in time frame I have here. So you can see the peaks that happen in the very beginning of hospitalization, Omicron and so on. And you can see compared to what's going on now, it's still down. So overall, that's a good thing globally. And I think someone else, I forget who it was, pointed last week that maybe it was Diego, that there was globally now it seems to be more in sync what's happening as opposed to previously in the beginning. There's always a lag. Sometimes it happened in Europe first, and then the lag happened in the U.S., then South America or Asia, and then or wherever it would originate from. But now it seems like it's almost a universal trend happening, no lag. But this is what I have for this week.
Maybe.
Yeah, go ahead.
Sorry. Yeah, I just think that maybe the lag is more generalized, and so it looks like there's no lag, just because genomic surveillance dwindled down for all countries.
Yeah, no, that's a good point. And before we had better case surveillance, right? So we could actually see the details.
As well. Yeah.
Yeah,
Afshin?
that's a good point. Yeah.
Do you have any information about what's happening in Australia or New Zealand? I have seen there's maybe some reports, but I don't know if the reports of deaths or cases are just very delayed. Do you know anything?
Following that? No. Yeah. What exactly have you read? So I should look into that.
No. Just I was wondering if because of the winter, it was some cases increasing. In Chile, there are some RSV and influenza cases rising, but not too much about SARS-CoV-2. But I don't know anything about Australia and New Zealand, all the countries in the southern hemisphere. So I just was wondering if there is any trend that we can follow. But you said already that there's not the case, no? It doesn't look like that.
Yeah, we could look quickly now in real time to answer your question.
Sure.
So here's Australia doesn't. Australia actually does report hospital patient ICUs. See, Australia is, I guess, the top one, a little upward trend. Zealand, case numbers. I don't think anyone's reporting case numbers anymore. So, New Zealand's here, the blue one. So, yeah, they don't. Unfortunately, Australia and New Zealand are not reporting hospitalizations, but Australia is reporting the patient ICUs. The deaths themselves are fairly low everywhere, except for these weird spikes that happen here and there. I'm not sure how the data looks weird. I'm not sure if that's an anomaly, but I guess for the ICUs, if you want to go by that, Chris, it looks like Australia might be increasing a little bit.
Yeah, ICU could be a good measure, yeah.
So it could be what you're saying, it's winter time there and could be a little trend going up. I believe the variant there is, I don't know what the variant is, but I think it should be, because 1.9, 1.9, is that the right one I'm thinking of? Yeah, 1.9 started around Asia, like Singapore. I don't know if that's the variant that's transferring over to that region or what variant's there. That's something we could look into.
Thank you. Very informative.
Yeah, thanks, Chris. Yeah. And then I didn't provide much information other than doing the real-time data look.
Sure.
Yeah, sorry for not providing more. But is there any comments or other questions or things that people know that I want to bring up? And then, I see Riza has put another nice article here from looking at shingles and COVID. People want, this is the article. Click on the link, looking at could COVID trigger shingles. So I'll take a look at this afterwards. Thank you. Okay, so I guess, as I said, the next 3 Fridays I've canceled. You probably got the calendar invite since I'll be away due to meetings and traveling. and our next meeting will be on July 21st. So hopefully there won't be another spike happening before then, and the trends will keep going down. But I hope everyone has a good few weeks at the starting of summer, and we'll talk soon.
Thank you, Akshin. Take care. Thanks, everyone.